Jennifer, from Jennifer Grigliano, who is the Chief of Staff for the Bureau of Water Supply for the New York City Department of Environmental Protection. And Amy Shawcross, who rescued us from our website just a moment ago in our chat box. Thank you, Amy. Amy is the manager of the Water Resources Operations for the Delaware River Basin Commission. And both Amy and Jennifer are incredible assets and resources for us. They respond to every request we ask of them and every piece of information about all of the programs that affect our tailwaters and the reservoirs. And so much of it is so complicated. They do a great job of explaining to us, how things work. And, we're not always happy with that. And we sometimes have spirited discussions, but Amy and Jennifer are stalwart in their efforts to make sure that, what they're doing for the Delaware River is just, really useful to audiences like this one, and they are readily available to us. So we thank them for coming today. Amy, it looks like you're already ready to go here. You're going to go first.
Yeah, we're just Jen asked me to talk about salinity and the implication for upper basin releases, sort of like an overall planning, and then she's going to just add some comments at the end about salinity and New York City's reservoirs. So I know most of you are familiar with the Delaware, but these are a couple of statistics that we usually bring up. Since you guys are in the upper basin, I thought I'd just kind of show you the whole map. The river is 330 miles long. That's from Hancock, New York to the mouth of the Delaware Bay. And the entire Delaware River forms the interstate boundary between 4 states, New York and Pennsylvania, New Jersey, and then New Jersey and Delaware. The watershed drains about 13,600 square miles in 4 states. That's like 0.04% of the landmass of the United States. And it provides drinking water for 5% of the US population. The water withdrawals in the basin exceed 6.4 billion gallons a day. That's the size of Blue Marsh Reservoir in the Schuylkill Basin. As you know, there are significant exports to New York City and New Jersey. New York City can take up to 800 million gallons a day out of the basin, and New Jersey can take up to 100 million gallons per day out of the basin. Jerry Kaufman of the University of Delaware has estimated that the Delaware contributes over $21 billion in economic value to the region. And also, as you probably well know, there are 2 Supreme Court decrees related to water withdrawals or out of basin diversions, and both in 1931 and 1954. So you guys wanted to know about salinity. Well, in the Delaware estuary, that is the river below Trenton, New Jersey, there is where water from the ocean mixes with fresh water from the land. And there are people, you can use water in that area because it's not so salty that you can't use it. Of all of the withdrawals in the basin, 76% of the water withdrawn daily from the basin is from the tidal river, which is the river between Trenton and the mouth of the bay. That's primarily, say above the Christina River, where people actually use water, but there are water users throughout the bay. So the types of water users that we have are drinking water providers, and the picture on the upper left is the Philadelphia Baxter Water Treatment Plant. On the top right, that's Evonik. They are a specialty chemical manufacturer. On the lower left is the Kimberly-Clark paper mill. Remember, toilet paper was an issue recently, and they do a ton of different paper products. And then on the lower right is, I believe it's the Hope Creek nuclear power plant. That's basically a base load power facility. And so there are, so the water in estuary is actually a very big resource for the region, even though you might not think it's usable because it's slightly salty. So in the 1960s, though, there was a very bad drought, as I'm sure all of you are aware of. And this is what it looked like. On the right is a picture of the Delaware River at Trenton. You can see it looks like there's puddles in the river. There's no river. And as I mentioned before, 76% of the water that gets to the estuary is from the watershed above Trenton, not the Schuylkill River. 50% of the water, or 70% of the fresh water into the estuary goes, it's 50% of the fresh water into the estuary is from above Trenton, and 15% is from the Schuylkill River. The picture on the left here is of, a snapshot of sort of the top of the tidal river. Up here would be Trenton. I don't know if you can see my cursor. Here is the drinking water river intake for the Baxter Treatment Plant in Philadelphia. And on the other side of the river now is the New Jersey American Water Company intake. In the 1960s, there was a significant use of wells in Camden from the Potomac, Raritan, Magathie Aquifer, PRM. And in the 1960s, the what they call the salt front, which I'll talk about in a minute, got up to River Mile 102. And they felt that there was significant saltwater intrusion into the aquifer at Camden, and plus that it was getting scarily close to the drinking water intakes. Now, the salt front is what we call, is that the 250 milligram per liter chloride concentration and a 7-day average of that. And it's the 250 milligrams per liter is based on drinking water quality standard, and it can affect taste and odor of water being treated. And then also there are people who have sensitivities to sodium. You can't take that out of the water unless you use reverse osmosis. So if the salt water gets upstream closer to the drinking water intakes, they can have problem with treatment. And then also when salt gets high, it can start to corrode some of the intakes. So if the salt water got all the way up here, it can really affect the water users down in this area. Now, for the most part, the salt front or the higher salt concentrations or the unusable or less desirable salt concentrations are between River Mile 69 and 76 near the Delaware River Memorial Bridge. So after the drought in the 1960s, I'm sure you all know that the terms of you're familiar with the terms of the Supreme Court decree that New York City needs to make releases to meet Montague. But after the 1960 drought, it was determined that they could no longer do that. And so what the 4 states and New York City met at DRBC, and they negotiated revised terms. And some of those terms include a salinity management goal, which was to keep a maximum 30-day average of 180 milligrams per liter of chloride at River Mile 98. And that was to protect drinking water, both in the groundwater, Philadelphia Water Department, and now the New Jersey American Water Company. They identified different storage that should be pursued to repel salinity. They established drought operating rule curves. They created the Trenton Flow Objective. The Trenton Flow Objective was not part of the 1954 decree. It was created as part of the Good Faith Agreement. There are phased reductions in diversions and flow objectives. It allowed for banking of excess water for other purposes. And excess water, you probably know, is the ERQ or the IERQ. It provided for enhanced conservation releases during normal conditions. That is the docket D7720 revision 1. You'll hear people talk about revision 1. And then it also required water conservation and consumptive use management. And this is just kind of to show you where the river is. So this is zone 2 near the top of Philadelphia. And this is zone 3. Zone 3 is where that criteria of the 30-day average of 180 milligram per liter chloride, that's sort of the salinity management goal. So to keep the salt below, at River Mile 98, to keep the salt below 180 milligrams per liter on a 30-day average. So where do you get all the water to do this? Well, the drought management plan is based on the combined storage in the New York City reservoirs. And as you go into a drought, this is basically those phase reductions that I briefly mentioned. As you go into a drought, the amount of water that New York City and New Jersey can take is reduced, and also the amount of water that needs to be released for Montague and Trenton is also reduced until you get into a drought emergency. And then the amount of water released is based on the location of the salt front. So primarily the New York City reservoirs make releases to meet Montague, but in a drought emergency, water can be released from those reservoirs to meet the flow objective at Trenton. There are also other reservoirs, primarily 2 federal reservoirs that we use to make releases to meet the flow objective at Trenton. So this is sort of a diagram of that drought emergency flow objective. And so as the salt front moves upstream, right? So when it's downstream, the flow objective is low. And so less water is needed, or less water is released from the reservoirs to meet the flow objective, or basically the flow objective is lower. But as the salt front moves upstream, the amount of water that is required increases. So basically, the further upstream the salt water gets, the more water you're releasing to push it downstream. And just for reference, during the drought of record, the lowest monthly average flow at Montague was 870 cubic feet per second. And at Trenton, it was 1,550 CFS. So at Montague, now the desired lowest flow rate would be 1,100 cubic feet per second. And at Trenton, the lowest flow rate would be 2,500 cubic feet per second. So basically, you're trying to increase the amount of water getting into the river by at least a third. So I mentioned that there were enhanced conservation relief. I'm trying to show you how everything is sort of integrated. So based with the good faith agreement, they started these negotiations for D77's 20 CP and revisions. Those are known as the experimental fisheries release programs. And so in the 1950s, before it was a decree, then the decree was in place for this much time. There were no required conservation releases on the decree. And then the commission and New York City and New York State created a docket D7720, and that was the first fisheries program that created augmented conservation releases during non-drought conditions. And then as the years went on, the experimental fisheries program has been modified over time. And then, to modern day, now you have the flexible flow management program. The reason why I put this up here is because you can see that there's been a lot of work done on the fisheries program, but there hasn't been a commensurate amount of work on the drought management or salinity management program. So that is somewhat what the FFMP 2017 studies are seeking to do, is look at salinity and managing that problem possibly in a different way. So part of what's driving that is what might change that affects salinity. And that is, in addition to climate change and the amount of fresh water that might be available, it's sea level rise. So if you look at this kind of theoretical estuary, the box on the top is what we have now, where if this on the left is the ocean and this on the right is Trenton, you can see there's fresh water pushing downstream and salt water pushing upstream from the ocean. And right now, it's sort of like the equilibrium area is around river mile 68 to 76 or something like that. But if you have sea level rise, there's a lot more force pushing salt water upstream, and you still have basically the same amount of fresh water coming downstream, kind of indicated by the size of the arrows. And so where is this new kind of place that the salt front likes to hang out going to end up? And so we're doing some work to try and figure that out right now. And so
Amy, I'm just jumping in. It's a 5 minute.
5 minutes? Okay, good. I think I'm in good shape. So this is the projected sea level rise at Lewes, Delaware. So this is at the mouth of the bay. And this curve was starting at the year 2000. So you can see we might already be at, like 0.7 or 0.8, between 0.5 and 0.05 or 0.08 meters of sea level rise already. And then by 2034, under worst case conditions, we could be at 0.3 meters. And by 2050, under worst case conditions, by 2048, we might be at 0.5 meters. And then it looks like there's a really good chance that by 2060, we would be at 0.3 meters. So this is kind of what is coming our way, is that sea level rise is going to increase that much. So we took all that information and we put it into our planning model, and we looked at where that at 180 milligram per liter 30-day average chloride concentration would be. So it's like a different salt front, the 180 milligram per liter. And so this is in the 1930s. You can see that with 0.5. So the simulation of historic flows in 1930s, we would be exceeding the criteria. In 1957, we would be exceeding the criteria. And then also in the 1960s, we would be exceeding it. And for a long period of time in 1964, and then also in 1965. So this is a lot, brings up concern, is like, are we going to have enough water to send fresh water down? This is a simulation of the FFMP 2017. So I looked at what is the combined storage that might be needed to have water available to release if we wanted to create a new program to do that or adjust the current program. And from this, you can kind of see that at 0.3 meters, based on the current program, New York City's out of water. They don't have anything left to use to repel the salt front. But there is some water left in the lower basin. And if we also added water at F.E. Walter, we're looking to add maybe 5 billion gallons of drought storage at F.E. Walter. We might have some extra water from the lower basin that we could use to repel the salt front. So this is a picture of F.E. Walter on the left here. And what we're looking at is potentially, right now, F.E. Walter, assume this line here is 1370. F.E. Walter uses this much of their flood control space for recreation. And they use it temporarily. And if there's a predicted storm that would come and fill this space, they would actually release all the recreation water. And what we're asking them to do is to store a little bit water a little bit higher during drought conditions so that we could use that to manage drought. And right now it's technically would only be available in the second year of the drought. So, but F.E. Walter is essentially empty for 6 months out of the year, from like October to March, I guess 5 months out of the year. And this is what it looks like down here when it's empty. So maybe there could even be a permanent pool in F.E. Walter. So I'm not going to go over that, so Jen has enough time to talk. But anyway, so just kind of to summarize what I've gone over is that, I got to draw my numbers right, but basically 66% of the flow in the rivers is in the tidal river is from the watersheds above Trenton and Philadelphia. The estuary supports a variety of water users, including drinking water, industry, manufacturing, and recreation. Salinity has been a long-standing concern in the basin. Unlike the fisheries program, the salinity drought management program and its components have not been adapted over time. And that's part of the reason why we're looking at salinity in the FFMP 2017 studies. Sea level rise and chlorides present the greatest challenge to use of water from the estuary. And work is underway to understand those challenges and to develop or modified strategies to manage these issues. And Kristen's going to talk to you about some other storage projects other than F.E. Walter that we're looking at. But now I'm going to turn it over to Jen so she can kind of speak to the upper basin perspective.
Right, so I'll be quick because Amy presented a lot of science, and this isn't a topic that is necessarily new to this group. Amy and I have presented this before, and we've presented this up and down the basin, and a lot of times we get a question, why should I care about this subject? We get that when I'm talking about New York City storage in the lower basin, and we get that from upper basin groups, when we're talking about salinity in the lower basin. And I think it's important, to remind everybody that, 2017 FFMP is a flow management strategy for the entire basin, and it takes a lot of things into account. And, myself, Amy, all of our counterparts with the other decree parties have put in a lot of time and effort to go through these issues to see if we can improve upon, the strategy that we have in place, because what we're finding is that the effects of climate change, we don't meet the mark in several different areas. So as Amy presented, the New York City releases are tied to the position of the salt front during drought emergencies. And if we keep the current strategy in place, New York City doesn't have enough water in its reservoirs to not only meet demand, but to also not make releases downstream. We run out. And I don't think anybody thinks that that would be an acceptable thing. We wouldn't be able to meet demand. We wouldn't be able to push water downstream. That affects the lower basin as much as it affects the fisheries up here. We broke up 2017 FFMP specifically because, doing a full-blown, comprehensive analysis of the basin is extremely difficult and it's very resource intensive. So we're breaking it up into different studies in hopes that we can build upon each of those studies and pull together all the bits and pieces that we need at the end to create a new program. So this is one area that you should care about. Storage from Effie Walter, what we're hoping to do with it is kind of like the thermal program where Brennan takes water and he makes pulse releases, to combat the heat. What we're looking to do is to take water from Effie Walter and make pulse releases to combat the salt. So similar, using the pulse release theory to be able to do that, and hoping to get the Corps to change their practices to implement forecast informed reservoir operations like we use in New York City, which helps us predict how much water is going to be in the reservoirs, how much can be released from the reservoirs. Same concept applying it to the lower basin. Corps of Engineers already uses this strategy out west. They're using it out in California. We're asking them to bring it here so that we can help conserve water in the New York City reservoirs, keep the storages higher so that we can continue to make releases during times of drought and to be able to meet demand during times of drought. So, this is big work going on, by a lot of people. All the decree parties are engaged in it, not just, New York City and DRBC. Everybody's got a stake in the game here. So this is one issue that you should really care about. So I will leave it at that so that we have a few minutes to take questions as I see a bunch of them coming into the chat.
Thank you both. I am going to start at the top here. Walter Deck is asking, Amy, has water temperature ever been considered at Montague or downstream? Are dissolved solids a function of water temperature, at least to some extent?
Not that I know of, but we have a very good water quality specialist in my office that can speak to that, and I will put you in, I will connect you with him if you just have Molly send me your email information.
Sure. So the next question I think we're going to address in just a minute, but if there is anything you want to add, Amy or Jen, about the discussions of the feasibility of raising the Cannonsville Dam.
So that is something that was looked at, and a feasibility study was completed, and it was found not to be very feasible. So that idea is no longer alive.
Yeah, that was one of the things that was, suggested that be pursued in the good faith agreement. I'm not sure to probably phrase that. And New York State DEC did look at that, and I believe that they did not really feel that it was cost effective to do it. But we can dig that old study out as well.
Okay, and Lee Hartman is asking, how much water is being saved by fixing the leaks in the Delaware Aqueduct?
So Paul is going to talk about this later on. His presentation is all about fixing the Delaware Aqueduct. So I will leave that one for Paul.
Okay, Amy, how have releases from Wallenpaupack addressed holding back the salt line? And can you help Jeff with his Zoom background and lighting?
I don't even see Jeff right now. So, like a long time ago, in a lower basin drought, releases from both Lake Wallenpaupack and the Mon Gap system can be made to hold back the salt line. So they are engaged in a lower basin drought. In a basin-wide drought, those releases are coordinated with New York City to help in assisting repel the salt front. So basically, there are times when water from Lake Wallenpaupack and the Mongap system are used specifically for repelling the salt front. It's water code section 2.5.3.6.
Not that you have to look at that very often, right? Okay, Clay Smith is asking, what are the projections for increased rainfall, as mentioned by Dan, and its impact on this issue?
So we're doing a project right now where we're looking at different models and different climate models and their impact on rainfall. And what we're seeing is that we're not going to get rainfall, like annual rainfall amounts as low as we have in the past, and not bunched up as low as we have in the past of the drought of the 60s. So we might have some short periods of low rainfall, but it looks like that we're just generally going to have more water. So we're going to carry that analysis forward to how does that affect flow and water availability, and hopefully that information will be out within the next year or so.
Okay, and last question from the chat. Was there ever a circumstance with salinity concerns that affected release considerations by Brennan?
The thermal releases, like tying the thermal
I
releases.
think that must be. Joseph, feel free to clarify if that's not correct.
This is Brennan. I don't think that there's ever been a conflict. Generally at the time of year when salinity releases are made, it's past the real thermal threat period. If there was a conflict, it could be that either a release for Trenton would, replace the need for a thermal release or vice versa. One thing to consider is the time of travel is about 15 hours to Lordville, and it's about 5 days to Trenton. So there's a little bit of a time offset there. But yeah, that's one thing that the River Master takes into account when we're determining the release to direct to the city.
Okay, thank you all very much. That's the end of the questions.
Great, thanks, Jen, and thanks, Amy. We're a little bit behind, but I think we're okay. I think we can make up for it in the next session. So